Today we're going to start with some vocabulary about circles. And many of these terms and concepts and vocabulary you've heard and you know what they mean, but we want to talk about them from a geometry lens. So the first thing we want to talk about is a circle. And by definition, a circle is just going to be the set of all points. So it's a set of all points that are equidistant from a common point, and that's called the center. And so all of these points are going to be equidistant. And here we've got the arrow pointed to the center. And again, we know that all of these points on the circle are going to be the same distance from the center. And if we keep going, we know that that distance from the center to any point on the circle, that's just going to be our radius. And we can draw another radius here, and we could draw many more radii as we go around the circle. And yes, I did just use a word you may not have heard before. Radii is just plural for radius. One thing I do want to point out that I didn't point out above, when we're talking about a circle, let's say that I named the center A. Many times we will call that circle, we could call it circle A, denoting the name for it, and that just A specifies the center. Another thing is we can use the symbol for a circle, which is just a circle with a center in the middle, and we could call that circle A. So we do have that symbol so you can abbreviate and not have to write out the word circle. So a word that may be new to you is a chord, and a chord is just going to be a segment whose endpoints lie on the circle. That's really important. So it's going to be a segment whose endpoints are going to lie on the circle. So here we see that we have a chord CD whose endpoints are points on the circle. And then we have this chord called AB that its endpoints are also on the circle. But that chord AB is special because it goes through the center. So if you have a segment or if you have a chord that goes through the center of the circle, then that's just called a diameter. Again, a diameter must go through the center, and its endpoints of that segment must be on the circle. So the endpoints right there. Another vocab term that may be new to you is a secant. And a secant is going to be a line. It's important that you realize it is a line, which means it goes on forever and ever in both directions. And we see the arrows going on there. And a secant is going to be a line that intersects a circle at exactly 2 points. So we see right here those points that I'm highlighting there in pink. Those are the 2 points where the secant intersects the circle. And it's important that a secant has 2 points of intersection, because if it only has 1 point, it's what we call a tangent. And a tangent is going to be a line that intersects a circle at exactly, that's very important, at exactly 1 point. So here we have a tangent, and it's going to touch the circle just at that 1 point right there. So exactly 1 point. And the point where the tangent intersects the circle, that's called the point of tangency. So that point is called the point of tangency. And you see this depicted in this diagram below, where we have a circle and a tangent that touches at 1 point at that point of tangency. So let's talk about a few more terms. The next one is concentric circles. And concentric circles are just going to be circles that have the same center. They have different radii, so they've got different radii. So there's a radius right there for that inner circle, and we have a different radius if we look at that circle that's the next one out. And that's going to be different from the radius that goes all the way to the outside. But they all share that common center. Now, that's different. Concentric circles are different from congruent circles. Congruent circles are circles that have congruent radii. So their radii, or each radius, is going to have the same length. And let's take a look at some more examples. So here, we talked about this at the very beginning of the year, But here we have circles that are inside these figures, inside the triangle or inside the square, and these are called inscribed circles. And if you remember, when we talked at the very beginning of the year with the Euler line and all our constructions, the incenter of a triangle is actually going to be the center of the circle. So the center of this circle, of the circle, is the incenter of the triangle. Okay, and if you remember, the incenter was just ended up being the intersection of the angle bisectors of the vertices of all the angles in the triangle. Now we also have circumscribed circles, which means that the circle's on the outside here. And if we look at our triangle, the center of this the circle actually is, so the center of the circle is the circumcenter of the triangle. And if you remember, that was the intersection of the perpendicular bisectors. Perpendicular bisectors here. And if we draw the radii from the center of the circle, we see it's going to go hit all of the radii goes to all the vertices of the triangle there. Okay, so we talked about concentric circles where they're going to have the same center but different radii. We also could have externally tangent circles, which means that those circles are touching at exactly one point. The other thing that you'll notice here is that there is a segment that joins the two centers. It passes through the point of tangency. So we can see the point of tangency right there between the circles, and then the segment that joins the center passes through that point of tangency. We also have internally tangent circles. You can see this is the center of the small circle, and then this is the center of the bigger circle. And you see that here, these circles are tangent at this point right here. One is inside the other. So that's when you've got an internally tangent circle. Now we also can have common internal tangents. And here you notice that the circles themselves don't touch each other, but we can draw a tangent line that is tangent to both the smaller circle and the larger circle. Now, what you notice is that there is a faint line that's joining the centers of the circles, and when you have common internal tangents, you know that the segment that joins the two centers is going to intersect the tangent. So the segment that joins the two centers intersects the tangent. And then we also have common external tangents. And common external tangents, you see that we have a line that's going to touch both the circles, right? But what we notice about those two tangents is it does not intersect that segment that joins the two centers. So here are external tangents outside both of the circles, and they're both of those tangents are tangent to each circle. We've got a point of tangency here and here, as well as up there and there. Okay, so we have a few more just diagrams with different tangents to take a look at. So here we've got two circles, and we've actually drawn 4 common tangents. You'll notice that these tangents here, those are internal tangents because they would cross or intersect that segment that joins the two centers, whereas these outside segments right here would be external tangents. So those are external tangents, on this outside. And then here on the inside, we've got internal tangent. So that's going to be an internal tangent, and this is going to be an internal tangent, internal. In the next figure, you see we've got the two circles that are touching each other. And so in that particular case, we can only draw 3 tangents. 2 of them on the outside, those are external tangents. And then you have those 2 circles that are tangent to each other, and you do have that tangent line that they share. Then we've got some overlapping circles, and we only have 2 external tangents there. Here in the next one, we only have 1 common tangent, and those circles are internally tangent, right? Because one's inside of the other. And then lastly, we have some concentric circles, and concentric circles are going to have no common tangents. Because if you drew a tangent of that inside circle, it's going to end up being a secant of the bigger circle. So let's look at a situation and something we could do here. So they say draw a circle with radius 12. So if you go into the draw menu in OneNote, you can actually choose a shape, and it looks like an ellipse, but you can actually draw it to be pretty close to looking like a circle. So here we've got a circle O, which tells me that the center here is at O. They tell us that the radius is 12, and they want us to draw radii OA, so I'm going to call this OA, and then also radii OB. So here's OA, and I'll draw OB as well. OB. And they tell us that this is 120 degrees. And they want us to find the length of AB. So you'll notice here that we're forming a triangle. Well, it may be easier if you just pull this triangle out to the right. So I've got this triangle OAB. And because OA and OB are radii, we know that those are congruent. Now, this ends up forming an isosceles triangle. So I could actually draw an altitude from this vertex angle to the opposite side. And we've learned that if you're in an isosceles triangle, that altitude is going to bisect the other side of the triangle, and it's also going to bisect this angle. So we originally started with an 120 degree angle, which means that now each of these angles has to be 60. So because we've got a right triangle, we now can recognize that we have a 30, 60, 90 right triangle. So if I come out here and I know this is a 30, 60, 90 right triangle, they told me that the radius was 12. So I know that OB is 12 and I know that OA is 12. So if I know that, we know that the shorter leg is going to be half of the hypotenuse, because OB is the hypotenuse in this triangle. So my shorter leg here is going to be 6. And then my longer leg is going to be 6 times radical 3. And I know the same thing's going to be the case for this length over here, which makes this whole side of my triangle 12 radical 3.